All right, welcome to lesson 4, greatest common factor and least common multiple, word problems. Okay, so before we begin, we need to talk about some key factors to keep in mind, or some key questions to keep in mind when we're looking at word problems for greatest common factor. Okay, so first we need to ask ourselves, what is the question asking us? Do we have to split something up into smaller sections? Are we trying to figure out how many people we can invite? Are we trying to arrange something into rows or groups? All three of these descriptions could mean that we are solving a greatest common factor problem. Okay, next we need to talk about what we would need or what type of problem we'd be looking at for a least common multiple word problem. So again, we need to ask ourselves, what is the question asking us? Do we have an event that is or will be repeating over and over? Will we have to purchase or get multiple items in order to have enough? Are we trying to figure out when something will happen again at the same time? Okay, so let's look at our first example. Now, while we're looking at these examples, you're going to, 1, want to have your factor chart out, 2, have your multiplication chart out, and 3, have your cubes foldable out, okay? And that helps us with word problems. So, example 1, Samantha, a costume designer, has 36 bat buttons and 18 black cat buttons she must use to create costumes. In her costumes, she used both bat and cat buttons. What is the largest number of costumes that she can make? Okay, so first of all, we're going to use our foldable to highlight the important information. So we know we've got 36 bat buttons, so I'm going to circle that. And we've got 18 black cat buttons. Okay, now we know that we're looking for what is the largest number of groups. Okay, ooh, largest might be a key word there. So let's go ahead and underline that keyword. And then we want to be able to box the question that we're trying to answer. So I'm going to go ahead and box what is the largest number of costumes that she can make. Okay, and now I'm going to go through and I'm just going to cross out any information that we no longer need. Okay, so Samantha is a costume designer. That's great information and that's a great job that she has, but we really don't need to know that. Okay, she has 36 bat buttons and 18 black cat buttons that she must use to create costumes. Okay. We can cross out that she must use because we know that she's using the buttons to create costumes. Her costumes, she uses both bat buttons and cat buttons. So again, we can keep the uses both bat and cat buttons, but we don't need the rest of that, okay? So this technique just helps us pare down some of this information. Now, again, we need to go back and ask ourselves, are we splitting the buttons up into groups or are we multiplying the buttons to make costumes? In this case, we know that she has a total of 36 and 18 buttons. So we're actually trying to figure out how can we divide these buttons up or split the buttons up so that we can make some costumes. So in this case, we can say that we are trying to find the greatest common factor. So we can circle greatest common factor down here. Okay, now to find greatest common factor, I'm going to use my F method. So I'm going to draw my F. I'm going to place 36 and 18 outside of my F. Then I'm going to go ahead and start listing all of the factors of 36 and 18. Again, you can use your factor chart if that's helpful to you. So I've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6. Now, some of my students were asking me, why do we only have to list 6 on top? Because we know that 6 times 6 equals 36, but when we're creating a list of factors, we really only have to list 6 once, okay? Now, let's list out the factors of 18. We have 1 and 18. We have 2 and 9. We have 3 and 6, okay? Now we're going to find the greatest common factor by circling any common factors in our F's. We've got 1 and 1, 2 and 2, 3 and 3, 6 and 6, and 9 and 9, and 18 and 18, okay? So in this case, our greatest common factor, or the greatest number that we circled, is 18. So our GCF is 18, which means that she can make 18 costumes. All right, let's go ahead, let's move on to the next example. Now, with this next example, if you want to pause the video and try it on your own, go ahead and do so now, and then you can come back to us as soon as you're ready to check your answer. So let's go ahead and do number 2. Landon has 60 peppermints and 90 candy corns. He wants to make packages of these candies to bring to his school and pass out to his classmates. What is the maximum number of packages that he can make so that there are no candies left over? Well, first, what we're going to do is we're going to circle any numerical numbers inside of our problem, okay? Now, we also want to circle any operation words. Now, with GCF and LCM, they may not look like addition, subtraction, multiplication, and division words, but I am going to say that this word maximum might be an important word, so I'm going to underline it, okay? This might help me in deciding if I'm finding the greatest common factor or the least common multiple. Next thing I'm going to do is I'm going to box the question that I'm being asked. So what is the maximum number of packages that he can make so that there's no candies left over? And now I can ask myself, I want no candies left over. So I know that I'm going to be splitting these candies up into extra packages. So if I'm dividing or splitting something up, I know that this is going to be a GCF problem. So again, I'm going to go ahead and use my F method by drawing my F's. I'm going to place the numbers 60 and 90 outside of my F's, and I'm going to go ahead and start listing their factors. For 60, I've got 1 and 60, 2 and 30, 3 and 20, 4 and 15. I'm sorry, I'm left-handed, so you can't see while I'm writing. We've got 5 and 12, and we've got 6 and 10. F a little bit bigger. Now, let's go ahead and list out the factors for 90. We've got 1 and 90. We've got 2 and 45. We've got 3 and 30. We've got 5 and 18. We've got 6 and 15. And we've got 9 and 10. Okay? Again, we're going to make our F a little bit bigger. So now what we're going to do is we're going to circle any of our common factors, 1 and 1, 2 and 2, 3 and 3, no 4, 5 and 5, 6 and 6, 10 and 10, 15 and 15, 20, oh, no, I'm sorry, not 20, that was incorrect, 30 and 30. Okay, so our greatest common factor is going to be 30, which means he can make 30 packages. All right, let's look at the next one. Hot dogs come in packages of 12, and hot dog buns come in packages of 10. How many hot dogs and buns must be bought so that we end up with an equal number of hot dogs and buns? So let's think about this. We're trying to figure out how much we need to purchase, okay, so that we have enough. So right away we can say that we're doing a least common multiple problem. So again, I'm going to circle any numerical numbers or words in my problem. I'm going to look to see if there's any operation words. Okay, well actually I'm going to underline the word equal. Okay. I'm also going to underline the word bought because we know that bought is a trigger word from our descriptions on the front page. Now I'm going to go ahead and I'm going to box the question that I'm being asked. How many hot dogs and buns must be bought so that we end up with an equal number? And at this point in time, I can say that since I'm talking about buying and buying equal amounts of something, I'm trying to find the least common multiple. I'm gonna go ahead and use my M method, placing the numbers 12 and 10 at the top of my M. Now I'm going to go ahead and start listing multiples. If it's helpful, you can use your factor chart for this. So I've got 12, 24, I'm sorry, not your factor chart, your multiplication chart. We've got 36, 48, 60, 72, 84. Now let's do tens. We've got 10, 20, 30, 40, 50, 60. Oh, I can stop right there because I can see right now that I can purchase 60 hot dogs and 60 buns, and then I have the perfect amount of buns and hot dogs. So my least common multiple in this case is going to be 60 hot dogs and buns. Okay, let's try the next one. Now again, if you want to pause the video, try this one on your own and then come back when you're ready to check your answer. That may be a good plan for you. So Mariana can make groups of 3, 4, or 9 pumpkins with none left over. What is the smallest number of pumpkins that she must have to make these groups? So I'm going to go ahead and circle my numerical numbers. I'm going to underline the word smallest because it's kind of like an operation word or a trigger word. I'm going to go ahead and box my question. What is the smallest number of pumpkins that she must have to make these groups? Okay. And now I can say by looking at this, I'm trying to make groups, but at the same time, I'm trying to figure out how many pumpkins I must have, okay, in order to have enough to make groups. So this is actually going to be a least common multiple problem. I'm going to go ahead and draw my M, placing 3, 4, and 9 at the top of that M. And now I'm going to go ahead and start finding the multiples. I've got 3, 6, 9, 12, 15, 18, 21, 24. I'm out of space, so let's move on to the 4s. We've got 4, 8, 12, 16, 20, 24. Okay. Now we're going to move on to the 9s. I've got 9, 18, 27, 36. Now let's check here if we've got any common multiples for our least common multiple. Here I've got 18 and 18, but not under my multiples of 4, so that doesn't work. I've got 9 and 9, but not under the multiples of 4. Okay, don't have 27 yet. All right, so we need to keep going. So let's do our multiples of 3. We stopped at 24, so I'm going to pick up with 27, 30, 33, 36. Let's see if that's enough. Now I'm going to do my 4s, 4, 8, 12, 16, 20, 24. We've got 28, so therefore 27 is not going to work. We've got 32. That's not an option. And we've got 36. Oh, I can stop right here because I've got multiples of 36 in all of my multiple lists. Therefore, my least common multiple in this case is going to be 36 pumpkins. So if I purchase 36 pumpkins, I can split them up into groups of 3, 4, or 9 and have none left over. All right, thanks for watching this video. Go ahead and check in with your teacher before starting the homework, and feel free to ask any questions if you have them.